Hello, welcome back. So, coordinate geometry. So, if you look at the name, there's two parts to it. There's geometry and there's coordinate. Geometry, you probably already know, it has to do with shapes and symmetries and all. Coordinate has to do with the Cartesian planes, the x-axis and the y-axis. And so, when you combine these two concepts together, you get coordinate geometry. Now, let's start with the very basic thing. Let's say a Cartesian plane. A Cartesian plane is just what you have been normally doing, but it's just that there's a fancy word for it. So in a Cartesian plane, you have the vertical axis, which is the y-axis, and you have the horizontal axis, which is the x-axis, and any point on this can be represented, can be identified by me telling you, this is something that's called the origin, by me telling you how much you need to move vertically, let's say 3 units, and how much you need to move horizontally. Sorry, I said the opposite way. How much you need to move horizontally, let's say 3 units, and how much you need to move vertically, let's say 4 units, right? And you will end up at this point. So any point can be represented by the x value and the y value, which in this case would be 3, 4, right? This point right over here would be 1, -2, right? Because the vertical displacement is in the negative direction. All right, so now let's talk about lines. There are, let's say, y equals 2x plus 1, right? And if you were to plot this, it will look something like this. Start 1, there's something like, there you go, right? So when I say y equals 2x plus 1 and I drew this line claiming that this is the line of 2x plus 1, what I am really doing is that I am treating my x as input, right? And I am inputting it into this function, right? And whatever output I am getting, that is the value of y at that point. So let's say at the x value 1, it's 2 multiplied by 1 plus 1, which is 3, and so this value of y is 3. I do the same for 2, for 3, and for all the values that are on the x-axis, right? And so once I connect all those points, I get this line. So there are a couple of different ways of representing the equation of a line. One is the simple old mx plus c, and there's another one that's y minus y1 is equal to m times x minus x1, where y1 and x1 are just any one point, and these two are really just the same formula. Now when you look at y equals mx plus c, this thing is called the y-intercept, right? The y-intercept is the point at which the line intersects the y-axis, right? So this green point over here, which turns out to be 0, 1, is the y-axis, is the y-intercept of this point right over here, right? And notice how, since we're talking about linear functions, i.e. we're talking about lines, every line will have some y-intercept, let's say this point over here, and some x-intercept, some point over here, right? So in y equals mx plus c, the c is the y-intercept, right? And the effect of y-intercept is basically that it just shifts the graphs up or down, right? So if this is, let's say, the graph of negative half x plus 1, this would be the graph of negative half x plus 2, this might be the graph of negative half x, and so on. You see that it merely just shifts it up or down. Now let's talk about this m over here, the mx in mx plus c, which here was 2. So this is something that is called the gradient. Let's change the color. It's called the gradient, and what it really is, it's that it determines the slope of the line, how steep or flat it is. And you can find the gradient by saying the change in y over change in x, right? So if I have any 2 points, right, and I have their coordinates x1, y1, x2, y2. I can get m simply by the formula y2 minus y1 over x2 minus x1. One way to think about it would be, say, if you have 1 unit change in x, how much is the change in y? Right, so if my m is 2, by 1 unit change in x, my y value will change by a plus 2. If my m is, let's say, negative half, then for 1 unit change in x, my change in y would be negative half, something like this. Right, and what the effect of m is that if the magnitude of m is greater, then your line is steeper. Right, so let's draw this line. Let's say this is y equals x. Right, then y equals 2x would be something like this. You can see that it is steeper. There's more change in y for the same change in x. Right, and then if I were to, let's say, half this would be something like half x. Right, half x. Right, and as long as my gradient is positive, my line is it's increasing, as in it's, if you move to the right, the line will be going up. It's a positive gradient. If my gradient is negative, it will be going something like this. Right, let's say this is y equals negative x. This, a bit flatter line, would be y equals negative half x, and a more steeper line would be y equals, let's say, negative 2x. Right, so this is the effect of the gradient. Alright, so now we are dealing with one line or one linear equation. Now let's say instead I have two lines, one like this and let's say another one like this. Right, let's say this is x minus okay, so let me change this a bit. Say something like this. Let's say this is x minus 2.5, and let's say this is 2x minus 2. Right, y equals 2x minus 2 and y equals x minus 2.5. I noticed that these two lines intersect at one point. Right, so what does intersecting at one point mean? What it really means is that there's a certain x and y that both of these equations share. So if y equals x minus 2.5 and y equals 2x minus 2, there will be a certain x and y for which both of these equations are satisfied. Right, and we know that for that certain y, this is true, and for that certain y, this is also true. And so if we solve these simultaneously, we should get our values. Right, so let's bring the 2 here. Negative 0.5 is equal to x. We got our x value. We can plug it back into the equations to get the y value. So y is negative 0.5, negative 2.5, which is negative 3. I can also put it in here just to double check. 2 times negative 0.5, negative 2, this is also negative 3. And so we got to know that this point is negative 0.5 comma negative 3. Right, you could also call this the solution of these two equations, or simply in the context of coordinate geometry, it's the point where they intersect. Right, one thing to notice is that not all lines will intersect. So if I have, let's say, if two lines have the same gradient, right, so if m is equal, then those lines are parallel and hence they won't intersect. So if this is y equals x, this would be y equals x plus 1. Right, remembering that the plus c is simply shifting it up or down, and hence since there's no change in the slope, these will never meet. Right, so if m is equal, then they are parallel and they never intersect. Alright, one more case is that, let's say, there's this line 1, let's call this line 1, and there's this line 2 that is perpendicular to it. Right, so being perpendicular really means that there's a 90 degree between them. Right, and in these situations there's a certain property that if this has the gradient m1 and this has the gradient m2, then m1 dot m2 is equal to negative 1. So let's say if L1 L1 is basically 2x plus 1, and L2 is something, right, something plus, let's say, 3. So if my m1 is 2, so 2 times m2 should equal -1, so m2 is equal to -half, right? And in general, if two lines are perpendicular and I have been given m1, then the m2 is basically you reciprocate it and then you add a minus to it. So if my m1 is 2, my m2 would be 1 over 2, and then change the sign, -1 over 2. Alright, and if you want a quick proof why it makes sense, so let's say for 1 unit change in x, my change in y is 2, right, plus 2, right? So this will be a line that will look something like this. When I rotate it 90 degrees, what will happen is that 1 unit change in x will become 1 unit change in y, and that plus 2 unit change in y will become minus 2 unit change in x, just by rotating, right? To show you this, let's say 1 unit here, 2 unit here, and if I try to rotate this, if I try to rotate something like this, you'll notice that I have rotated this 90 degrees, and this is the effect of this. And so we can draw the conclusion that all you have to do is you have to reciprocate it and then switch the signs. If it was a positive, you make it a negative. If it was a negative, you make it a positive. All right, and so if this will be my line that will be perpendicular, it will be something like this. Alright, one last thing that we have to talk about is angle between the lines. Right, so if I have this line and I want to find this particular angle, right, with the x-axis, or in generally with any horizontal surface. Right, one thing to notice is that for any y equals mx plus c, the angle it makes with the x-axis really just depends on this gradient m. Because if I change my c, what it will really just do, it will shift it up or down, but the angle still remains the same. Right, so what is m? M is the change in x over change in y. Let's say if there's 3 unit change in x, there's 2 unit change in y, this is my line. This would be theta, the angle it makes with the horizontal. Right, so just applying some basic trigonometry, we notice that tan theta will be equal to 2 over 3, which in general tan theta will be equal to the change in y over the change in x, which is just the gradient. And so we see that the theta will be arctan or tan inverse m. Right, so this theta would be tan inverse m. Right, now let's say there are two lines and we want to find the angle in between. Right, the simple thing we can do is first we find this angle. So if this is L1, L2 with the gradient m1 and m2, we can find this angle by tan inverse of m1, right? And we can find this angle by tan inverse of m2, and if we subtract these two, we'll basically get the angle in between. So tan inverse of m2 minus tan inverse of m1 will give me the angle in between, because this angle is basically just, it's something like this, right? Something like this, tan inverse m2. So if you subtract these two, you will get this angle over here, right? This angle. So in general, for any two lines, if you want to find the angle in between, this is the formula. You can reduce this to something a bit neater, but you can just simply apply this formula, because it also makes sense when you're applying it that you're finding the difference between these angles to give you the angle between the lines. Right, and so that's all for this video.